So in this video, which is the last part of the unintended and yet recorded series, I will show what the Debian and other distros init script does. We already covered how initramfs is unpacked and what are the microcodes that are in the unmake initramfs code. We already said what the initramfs init script does. It does all kind of initializations, then followed by a switch root. And in this particular video, what I'm going to do is to actually do a code walkthrough. Now, those who take my courses or been to my lectures know that I usually do some special, very like either narrow or init to show some initramfs around this concept, or when I talk about over-the-air update, installers, flashers, recovery and things like that, I do things that are a little bit more complex. However, I always say that once you get to a running init, you can do whatever you want, and usually prove it with example from the AOSP, show some Android, especially in my Android internal courses, and so on and so forth. So what we're going to do now is just do a walkthrough. My designs are not necessarily affected by that. Everything does the same things. And this is what the init frameworks are all about. And this is what init scripts are about. And I will just go over it with you. I'll try to make it short. And it is I don't really know the code, so I'm just doing it live. And I'll focus on what is important and mostly like for loading, not from network, because network code tends to be like very long, okay? But I can also do that. So in this time, as opposed to always, I will use VS Code simply because it's a little bit easier, at least for me, to work with it in when there are some shell script that I want to look at or search. I can see code that usually have like a Vim tags, but I just open it, okay? So last time we looked at it in Vim, and now we do other things. So let's start. Obviously, when the kernel is going to boot and it loads an initramfs, then we're going to go and do an init. Now here we have like some notes about the path, and here we have the word klibc. There are two types of switch root implementations. One of them uses code from busybox, the other one uses code from klibc, which is like very small, and the klibc project also implements dash. Just in case I downloaded it, and if I didn't, then I will. Yes, I did. And we can see over here that like the utilities that are implemented by it would be dash, gzip, kinit, which would have like the switch root, and klibc, which would have implementation of a very, very small libc. So I'm not getting into it like right now, but we'll have possibilities to generate, check it out, check out these things, like look, to generate like API functions depending on like an architecture. And if I, for example, look at like axi.c, then this is C implementation, okay? It is C implementation. But what we will have for like those system calls are very light wrappers that will just wrap a syscall. And the syscall itself will have to be like architecture specific. Here like under the user klib something, so let's see how it looks like for like the x86-64. So a syscall would be, as any of you ever like saw in an assembly code or like the libc system, it will be pretty much the same for everything. Syscall common, we'll put something like in the register and call it, okay? This is like a machine instruction syscall. So it moves to the register that is like being used. This is the syscall number, and this is a comparison to see if something is like not it's not like a negative number, and if it's like a negative number, then something is wrong and we need to set up error now, and otherwise everything is okay. So back to our code. So this is one implementation of klibc that implements all kinds of things and is actually not used by default, but you can, when you make the initramfs, and this is where the first config file comes in. When you actually make the initramfs, it tells you, hey, which modules you want to have. Would you like to use busybox or klibc instead? What kind of compression you want the initramfs to be? And so on and so forth. What devices you want to do, and which file type you want to have. Not really necessary. NFS root, like if you want to do NFS mounting. Basically, you will just specify like some parameters over the command line if you want that, or do like DHCP. You need to just provide the folder inside the server from which you do like DHCP if you do that. So what you have here also is like a run size, which will be the size of a tempfs. The difference like between tempfs and other file systems in memory, in RAM, would be that it can expand, but you don't want it to take like half of the RAM, which is like the limit that it can get. So you can go and just bound it to be like 10% of what you can have. Okay. So here it says overridden by optional initramfs.runSizeBootarg, which leads to something that the init will need to do, which is parsing. So it will go and parse the command line. Okay, this is like the first user space entry point. So even though the kernel itself knows to parse all kind of parameters, as you probably could see, if we went, for example, let's go to init. We'll have all kind of setup parameters here, okay? So one of them would be like the init itself, all right? Most of them, when you have like __ setup, then it's going to look at like a command line parameters, okay? So this is what it's going to look at, and it's going to set some files like according to it. So this is like the init setup. This is rd-init if you have like an rd-init parameter, and so on and so forth. So the idea is that when we already run this initramfs init, then it gets a command line and it can parse everything. So even if you already expect something from the kernel, the moment you use this initramfs, the kernel will not continue to parse the rest of the arguments once it passed control to it. So if you have a root equals device yada yada thing, it will be completely ignored because initramfs is now in control. So you will need to parse that. So let's go ahead and look what we do. We export a path. We create folders to mount a virtual file system into. We also make like var lock, sysfs, proc mounting. This is for shell check tool. You can ignore everything in this. Here we see if we have like in the proc command line the string initramfs clear, then we clear the screen. Clear would be part of something that is like in your path, okay? And in busybox it would just be like this applet. Here on systems that actually support, which right now is every system, the config of like parsing the U events. So the moment you do this, like dev tempfs /dev would be like automatically enumerated. But this does not mean that hot plugs are being taken care of. If you want to have some udev rules when you like insert a device and you want it like to automatically be mounted or something like that. So for that you need something that can handle this netlink socket of the U events, which would be in this particular case systemd udev. Okay, not the entire systemd, but systemd udev component. Here these links would exist, but if not, they just like take, hey, what is like the current process, and make symbolic links to that. Here we make like the dev pts for like the terminals, and initramfs itself will actually have like it will have like the current architecture. So if you run it like on RISC-V or like ARM64 machines, then it will look different for you. So back to the init code. I don't want to run over everything, but I do want to give you like the opportunity to understand and see the structure, okay? So here are some variables that are exported and will be looked at set. There are going to be, I'm going to completely ignore everything that is like under lib and bin because there are binaries. In conf there isn't too much, we already covered everything. And lib also, we covered in the previous video when I reasoned, hey, we don't need this framework, we don't need these modules, we can significantly reduce the size if we want to. And essentially, user is also out of the scope. So what we care about is init and all kind of helper scripts that are being used. We covered conf, and there are some more things that can exist under etc. Some of them we don't really care about, like LDSO cache. This is going to be a binary file that's going to tell, like in an encoded way, in a binary way, hey, what libraries and the linker should be like aware of. And we can also like provide like all these files. This actually came like from the preparation. Most probably check out like this chroot or fake chroot, because it was the bootstrapped by them and then sat over them. So we have where to search like for the library path. Okay, I already discussed linker like millions of years ago, so I'm not repeating that. Console setup can have like the key map and like the fonts, so you can use like a set font. I cannot change to the terminal, but for example, you can do set font -d, which means like, hey, double the size, and then you will have the and set a particular font file that is usually going to be gzipped, and then you will see that your console font is going to be like larger, for example. Of course, if you use like monitor and keyboard, if you use serial device, do whatever you want to do within, within your terminal software. So we have some console setup stuff. We have here all kind of like default parameters. Okay, so these are like the font that will be used, and this would be like the active console. Control Alt F this, Control F that. Keyboard definition, this will be like the default. And I'm not going to go over it, but for example, if we want to fall back to shell in the initramfs, which will be done by a function called panic, then you also want to set up like the console. Okay, so you can change all of these kind of things. This I do show in like my workshops, usually with the busybox DH client, UDHCPC. You can have DHCP hooks. So you know what, let's just go over it like super quickly. We have like enter and exit hooks. So we can see that like if this is a shell script and it receives a variable called reason. Bound means, hey, I have like a new DHCP bounding. Okay, the bound 6 is for IPv6. So on the bound, you get all kind of like environment variables set for free for you. So this is how, when you do like a DHCP, if you have like those hooks, the IP is automatically set. Now you can have like network manager or netplan. I'm not covering the networking part for a reason. Like right now it's like netplan, but not all distros use that netplan. So there's no point in going into like an internistics, and it will take like an hour, and I don't want to spend right now. So etc. So we cover default, DHCP we covered like the hooks. Okay, they are like for enter, and they're like for exit, like once we're done. We covered LD. Mode probe will have some blacklisted modules if you want to blacklist them. Okay, and we have some things like default parameters. Now check it out. This is like a very specific driver, like for the Intel Wi-Fi family, and it tells, okay, like if we do something like this, is the parameters that we set, or like when we want to do, or this is like, hey, if we want to take care of like the removing, this is exactly like how we remove it. These are like dependencies. These are what we have in mind. We also need to take care of that. So we're not taking care of this. Also base enables us to allow some audio, and I will not cover it. And as per UDEV, if you want, you can go ahead and add some things for like the demo. Okay. FS tab, if you really want to mount some folders, you can go ahead and specify it here, especially for a mount point for /user, which make the initramfs have like a richer OS. As you can see, now it doesn't have it. We cover the cache, cover the conf, and this is misleading because this mtab, it will show whatever is like on my own computer, because usually /cf mtab is just a link to mount proc mount, to proc mounts. So proc self mounts, which is okay. So NS switch is also like for libc to tell it I would like to resolve, for example, hosts like IP hosts. Okay. So we covered etc. We have some configurations, and now we can proceed covering what I said it matters, that is init and scripts. Now we have here, check it out. This is like a default init in the target root system that we will switch to. These are some default parameters, and according to command lines, we're going to change them. Okay. Some important things can be, for example, whether we want to force fsck, to force like a file system checking in the initramfs itself. If you boot to systemd and you don't work on a root file system that is like read-write, you can also go ahead and define on fstab the passes for fsck, so it can check all kind of things. We have whether read-only or not. We have whether to drop capabilities when we do like the switch root and so on. All right, this is for every time you see like md admin, it's going to be like for udev. Okay, if it needs like a hostname, so if we have like a hostname file, then we're going to call hostname control with this file. Okay, otherwise there's like a default kernel hostname which you provide. We source initramfs, and we source every file under confd. That's what we do here. Okay, in this case there is nothing. And now we're going to source script functions. One little thing about dot versus like this. I did not mean to do that, sorry. One little thing about dot versus like source. Dash does not support, it does not support source, okay? I like in my script to write source for two reasons. One, no offense, but I don't like dash so much. I try to make my scripts either busybox, ash compatible, or write them with bash. And the other thing would be that it's just easier to grep if like I see the word source. Now, something about shells that are not bash, you cannot like declare and then export functions. It doesn't work like this if the shell is not bash. You need to work hard to source functions. So if you want to export functions, then you would want, or use arrays or something like that, is also not supported if it's not bash. If you want to export functions, then to not work really hard or source some common definitions from every single file, you would want to go ahead and just like perhaps source a file and then call function from it, and then you're running within the same script and everything will happen. As I mentioned, here we're going to have parsing of the command lines. This is a switch case. It can do some regular expression matching. So init equals something. Here we go ahead and take whatever is after the equal sign. Okay. For example, as being init and so on. This would be like for a root parameter. Okay. And if the root is dev nfs, then we will know that we're going to use some nfs scripting in order to some scripts in the nfs directory there in order to mount the root file system via NFS. Now I'm telling you, you will see before every mounting, for example, maybe I want to just go ahead and wait for a root file system that is on a USB disk on key. Maybe I want to mount an NFS something from network. So we'll see that we are waiting for like the loading, unless there are all kind of parameters like no delay or like root delay 0 or so on. Okay. So I'm not going to cover all these parameters. If you're interested, you can go ahead and look at them. But we're going to see, I'm going over them like a little bit quickly. These are like some of the parameters that are provided. For example, if you want static IP, or you already got DHCP from your bootloader and you just want to provide it the IP, then you can go ahead and set the IP equals something parameter, and that would work just fine. Again, for NFS root, actually the kernel doesn't need any user space helper or anything, but because if this init file is running, then the kernel does not have the chance to do like NFS root or something like that. Whatever you want to mount from this point and on, you must do it yourself. This is why these scripts are like listed, okay? So here we also give like an opportunity for boot equals something. If we use a UBI based file system, then we need to actually also provide parameters. This is if we go ahead and do like suspense resume, and if we want to we need to go ahead and also, for example, take like whatever is like in swap it back, memory, and so on. And drop capabilities for switch root. Panic is what to do if like something in the script goes terribly wrong. In this case, then there are all kind of options what you want to do. The default would be revert to shell, but maybe you would just want to reboot or halt, and these are the parameters that are there. Debug will write, if you want to use some log files or use like a net console or something like that, then it's going to output to devk message. I'm waiting because I see that actually I don't think I ever looked at this file, but I do very similar things. Like my default would be to go like the devk message because we all do that. There is no other way really. But if you want to provide like a debug file, then you can actually go ahead and do that and check it out, set-x, which means that you'll have like tons of, hey, what we're doing. If there is debug equals something, then also, like in this particular case, they didn't really implement anything, but perhaps in another place they do. Break is important because if we do break without anything, then we'll stop at a place that is called like pre-mount before mounting like the root file system. Otherwise, you will see in all kind of places it's splitting between, hey, do something top, do something bottom. Do something top is before it will log something to a log file, if I remember correctly, and we'll see it soon. And if we have break equals on this do something, then you will get like a shell stop there, okay? And blacklist is like for modeling. If you want to specify hardware address, you can do that, and so on and so forth. And if you want to do fastboot, is not the end rate fastboot, don't get confused. It's just, hey, don't do like any file system skipping. And the rest of them are for repair mode for FSCK, which actually is also one of the reasons why in other videos I show how to build E2FS progs and DOSFS utils packages from source, because busybox alone does not provide for them. So it does not understand well the Linux file system. So you need to provide it with some extra executables, okay? But this is in other videos in YouTube. Maybe I'll link to them. All right. So this is parser, and from this moment on, we can go ahead and start looking at things. So here we go ahead, and we're going to mount run as a tempfs with run size. And if it was not provided, it was provided by the configuration file that we saw to be 10%, but here it's a little bit more. And now we actually go, if there is like a log output, then we're going to have like the current output from now on. We're going to have a redirection from standard error to standard output, and then we'll see. And now here is the thing. When I mentioned there is break equals something, you will see in several places the string maybe break. So maybe break top, maybe break modules, pre-mount, which was the default as we saw before, or mount root, bottom init. All these fellows, I will cover it very soon, means, hey, stop a shell here, okay? This is like how we do that. I will go over some things that happening here to quickly finish like the init script, and then we'll see some of the functions, okay? So maybe break, hey, stop here. Run script will take a directory, and we have these files. It will actually go and source the scripts by an order. And if we look at an order file, look what's going on. It's going to go ahead and run a script. It actually runs them, it doesn't like source them. and it's just going to run them like with the command that it's given, and after every time it's going to source this conf param.conf. In this case it's just empty file. So we'll see the same pattern for everything here. This is implemented most probably in functions, and there it is, like run scripts. If the directory does not exist, return, and then source order, and then order just goes and runs whatever it wants. So it will be like this in each one of these directories. Maybe break, as I mentioned, okay, it just stops. So since we already mentioned it twice, let's go ahead and see what it does. We can see here that if the case is not, if the argument here is not like a top, then it doesn't really do anything. Okay, this is like how it goes here, like with the loading of the modules, which means that we'll load the modules like one time, and then no matter what happens, we're going to go and just panic like on this function. In my implementation, I usually do something like stop at RAM disk equals a place, and then I add like a line pretty much similar to maybe break, and also tell it whether to exec or just spawn a shell to see if I want to return or not. Okay, so maybe break, and this just says okay, which is like the point where it decides to break. Does nothing with it except for the first maybe break where it loads some keyboard and modules. Okay, now since we're at it, let's see what panic does. So panic is going to change VT to the first virtual console. It's going to go ahead and see what is the delay parameter in order to see whether to reboot. What is the panic parameter in order to see whether to reboot or halt. It actually checks both of them, both like whether if there is delay, hey, after how much time you want to do the reboot or the halt. And then it's going to run all the scripts from the scripts panic one. After that, if we have a set SID, we're going to actually, will be the console. This is why we see initramfs like on some recoveries. We're going to, this allows set SID, allows job control, so you can do Control C, Control Z, FG, and so on. And the other one would just run it without like a job control. So this is how this one goes. And let's see if there are scripts in panic. So order like before, console setup. So console setup itself will for sure put fonts. Yeah, actually I also saw it here. So let's see what it does. I will not cover all of it. Code set, character mapping according to environment variables. Default font size, it will need to load the font somewhere. If TTY does not exist, TTY1, like for change VT, it creates it, and it's always going to be major 4 for this, for TTY, and then this is minor 1, and then it's going to go ahead and under etc console setup, as we mentioned before, it's going to look for like the selected font or default font, and then it's going to set font, this font, okay, in this device. So it does that, and it takes care of keyboard mode as well, and this is what it does. So this is what panic does, and let's just see the functions again. So these are setting up the console, okay, if there is no like reboot here. And after we set the console, we're going to go like to shell. So you can do some modifications. If you want to load another font, you need to provide it, of course. If you want to load another key map, you can actually change, we can mostly change environment variables for that. If you want to make like the font bigger, you can do like -D. If you want to set the font to have more spacing, you can provide it, I believe it's -H and then a number, like for the spacing between like the lines, and so on and so forth. I actually find the -D useful because with like monitors with with big resolution, the console will be very small, and you know, it blinds you, right? Okay, so we already covered, so this happens like only on the top, and we source the script from init top. Okay, so you will see everywhere that there will be like something top, run script something top, and many times like do something bottom. So at the end, almost at the end of the script, we'll have run scripts init bottom, and in between we have quite some logic. Okay, so let's have a look at that now. Run scripts init top. Again, order, all generic IDE takes care of blacklists and udevs. So all generic IDE looks at the command line and does module insertion. Blacklist, if we have in the command line, if we have VGA or video parameter, it blacklist VGA 16 FP so that there will not be collisions. And it also does it like in mode prop. It populates files. That's what it does. All right. If we have like any other like parameters that are blacklists in the list that was done for, and udev is actually going to go ahead and start the systemd udev daemon and do the first triggering like enumeration. So we can see trigger and action add to subsystems and devices. So this is like a discovery. Settle will mean, hey, wait. And you'll probably see it several times here as well. So this is this init top that we had. Okay. Now we have some messages. Log whatever means, hey, we're logging something. If we have a network console, we insert it. And load modules would be this one, probably under functions as well, so I need to find it. Yeah, so it looks if there is some configuration here, parsing. If it's a comment, it doesn't do anything, and then it goes and mode probe everything that it can. Excellent. By the way, the kernel, let's say if there are dependencies and you load something, then the kernel has like the mode probe helper or user space. It's that the API has been a little bit changed in recent version. There's something that more like explains that it's like comes from the user space, but you can have the kernel itself can also call like the user mode helper, which is mode probe, to resolve like all kind of like of dependencies. Now, if you have under your lib modules, if you have specifications of the modules that interest you, modeprobe can go ahead and do dependencies. Okay, otherwise you would see here like this loop, not with the modeprobe but with insmod. Okay, all right. So this is like the load modules, pretty trivial. Timekeeping routines. So uptime is a wrapper to uptime, but uptime also gives you some digits after the decimal letter. So for all timekeeping, then there will be like rounding up. So timekeeping will also be like in function most probably. And here again we have maybe break pre-mount, which was like the default one. So here we're going to do run scripts, everything under init pre-mount. So we're going to go ahead and look at that. And after that, there will be a search of the mounting of the root file system. So let's see what's happening in pre-mount. This will be hardware clock, NTFS3G, I have no idea what, and resume would be supporting resuming into like initramfs and then doing all kind of things. So let's see fix RTC. It wants to see if there is like a clock. If it needs to wait for a root, we did not see that yet, it will wait. If not, no. This has to do with already having like a file system, so it wants to dump it to FS. We have a hardware clock, and then it wants to go ahead and look at the date. NTFS3G, I have no idea why a root file system would be NTFS3G. I don't think I don't think it's applicable, to be honest. So this is what we have, and in resume this would actually show you if plymouth is like the splash screen, so it enables you to communicate with this. So plymouth display message, that's what it does, resuming from in a state of like suspension, and we have here like going ahead and touching like the sysfs for suspend resume to allow like the kernel to say, hey, like we're back. All right, next one that will be waiting like for a device and mount it. And there are several options. Local would be from block device that is attached to us. NFS will be trying to mount an NFS. And here we have like scripts boot. If there is like another method that is like provided, you can pack a run-init with all an initramfs with all kind of other things. So we're going to source these fellows, okay? And then we're going to go ahead and do mount top, mount pre-mount, mount root, and then mount bottom would be like the end. And if there is all kind of things that we used like for the NFS or the local, we're going to clean it up as the message here says, okay? And after that we're going to say, just like we had init up at the beginning, it's going to be some sort, it's not exactly the initialization, but it's going to be like the initialization in the reverse order of initialization, okay? So let's observe this script local. So this is local and it has all kind of functions here. So this would be like an object-oriented implementation. Each one of them would have like local top, local bottom, pre-mount and so on, and we're going to call like the functions over there. So if we go to init, we source them and we have like mount top, mount pre-mount, mount root and so on. So let's have a look at local first. So local top, it's just a message. Local block, run scripts, local block. I'll cover it soon. Local pre-mount, again running the script, so we're just going to look at all of them. I will not make it longer than it already is. I'll just split like I'll just go over some of like the functions. The important thing is that you can look at it yourself like if you want to. And device setup would be waiting for a device. So here you have it like you have like wait for udev, and here if it's like an mtd we have mode prop for it, and here we have like a sleeping for it. So while true, we're going to go ahead and wait until a device that we're waiting for is ready and available like in the file system. So if you have your root file system, you have your embedded device, you already know that you are running for an eMMC, you already know that it's there. You don't need to wait for anything really. If you want to do some removable device, then you do. If you can't find the device that you want, then you're pretty much done and you're going to panic. So the idea here is to wait for something, prove that it exists, and then set it like on the dev variable, okay? Once you have set it up, then you will be able to like mount it. But let's go back to the init. So what we first have here, as I mentioned, we said that we have like a sourcing of local. So we have here parse numeric root. Let's go again to functions. So parse numeric is going to go ahead and try to extract which device is the selected device here, okay? So it's going to look at dev block, major, minor, and see if it already exists, if it already matches. If we provide a root parameter on our switch case that was somewhere there, okay? So this is the first parsing, and then we'll see like if it's already ready, and if not, or if it doesn't exist, we're going to wait for something. So this is parse numeric. As I said, break doesn't matter. Mount top. So mount top, we started here with the local, right? Mount top does local top, and local top, it's just going to run scripts from local top. If it exists, it doesn't exist because there is no much to do here. It's just printing. It's not interesting. Great. So we're done with that. Mount pre-mount. Again, we're looking like for the local one. Local pre-mount and local pre-mount. We'll call scripts local pre-mounts. And local pre-mount is what we already covered before, for like checking like for the RTC and for the resume. Great. Mount root. Again, there will be like a wrapper here. Local mount root. And local mount root, if there is no root device, it will say, hey, you must have something. And usually like in Debian, you will have something like root equals, you know what, I can just show you. Like root equals UUID equals something, okay? Local device setup. So if there is like a root that is being set, we're going to look for it if there is something in fs tab and then see like how to mount it. And if not, then we don't do anything with it. You will not have something like in fs tab of the RAM disk. And this is actually absolutely unnecessary in like most cases. Usually you don't need to know anything, you can just call mount and that's it. But you want to figure out what is like the file system of it, and for this, forget fs type. There are probably going to be some block ID shenanigan, and that will probably be in functions. Yeah, so it looks at the device and it's going to search what is like the file system that it has. You can just mount in almost all cases, so it's unnecessary, okay? So this one was the local device setup. I think we already covered it. Yeah, so we look at the fs type, then we call local pre-mount, then we check what are the mount parameters. Then if there needs to be like a fdisk, then we're going to run not fdisk, fsck. We're going to run fsck, and there will be like the types according to the parameter, whether we want to force fsck with -f, whether we want to automatically fix, we're going to do y. And if fsck doesn't automatically either say that everything is okay or try to fix something, then we're going to fall back to shell, and it's going to tell you, hey, like it needs like user interaction. It's going to do that somewhere because there is like this message. Okay, so this was the checkfs, and after that we're going to mount the root file system. So mount whatever flags we have, read only, the file system. Mount can take care of everything, but you need to tell me if you want to be read write or not. And if things don't go well, then it's going to tell you, hey, I could not mount it, and maybe it's because of fsck and yada 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 yada. Okay. Now, basically what we can have here, this is why it says like about like the file system, we can set up a loopback device and use this as the root. Okay, so this is actually why they say about the NTFS and VFAT probably. Okay, to have a device on that file system, mount it as a loopback device, and then chroot to it. This was what the NTFS thing was, because it's probably like a use. This goes way back. Okay, so Again, it looks like the loopback device does this. If there is no loopback device, this, and then it mounts as loopback device, and this would be like the root file system that it mounts. So this is great, and this is the local mount root function, which comes from mount root. Okay, so back to mount root. This was called from init, and if we're here, we already mounted something, which is great. Now, if there is a need to mount a user file system, then it will mount this guy, and it will look like at etc, and then see what it is at etc fstab and c. And after we're done, we're going to do mount bottom. I'm still ignoring NFS bottom or local bottom. We're still covering local. So mount bottom will be, of course, local bottom, and local bottom is just going to say, hey, I'm done. There's nothing in it, okay? Just some log files here, except for, of course, run scripts. So we're going to go to run scripts in local bottom, and again we have this NTFS thing. It's probably going to, I can set it or something. So yeah, it's not interesting at all. So this is the probably nothing. It's just like common sense. Okay, so we had like the top, the bottom, we had everything in between, and by this time we have a root file system that is mounted somewhere, which means that if we want to, we can change root to it. We can switch root to it actually. So the bottom of init, before we do that, is in, we're going to go scripts init bottom and scripts init bottom. It will just run udev, and look what it does. We're done. We want to change root, which means that whatever we have in the /dev is not interesting for us anymore. So we're taking care of stopping the udev admin. We don't want plug and play there. Whatever we want to have, what with udev, let the new operating system, I call it the rich operating system, let the rich operating system take care of it. Okay? So we get rid of this. We move the current dev directory to the root mount point, and we get rid of the dev directory, and then maybe we fail to switch root, maybe the executable doesn't exist, and we still want to be working, so we still want to have like the devices accessible. I usually don't take care of that, like I said, because I said, okay, if you have some very bad problem, you're probably a developer and you're going to figure it out, or I prepare some automatic recovery mechanism if it's like at a customer's home or something like that. So that's what we do. We do the udev, and after that we move some of the mounts if we want to. It's very common to the root file system. Here we have something that is perfectly legal. It's a little bit ugly, but it's perfectly legal. We define a function in the middle of our logic. Okay, so validate init, what it does, with -n, it checks if it can switch root to root mount and run the init parameter, whatever is like selected here. -n is dry run, doesn't do anything. And if it's not able to validate it, here we have like a loop. If it validates succeeded, yeah, all right, we do init equals that. If it's not able to validate it, then we're going to go ahead and later on, like the run-init itself will not work. So we need to panic. But if it's able to validate it, we unset all kind of things so that they will not persist upon the switch root. Okay. We do mount move of sys and proc. And then we call the switch root again, run-init. Drop caps, whether to drop abilities or not. Root mount, this is our target. Init is the executable, and these are like the arguments to init. And here we do redirection of the console, both to input and output. And if this is wrong, then if the executable exists, we're done. Like we'll have a kernel panic because it will execute. But if the executable doesn't exist, for example, and like the exec doesn't even happen, then we are just going to have this panic message. So I will cover run-init soon. Actually, it would be a good idea to do another video for that, because this video is getting long, but you know what, I said I'll do it in one shot. Worst case, I'll do it again. Okay, so we talked about the first type, which was the local bottom, okay, which was local, and there is another one for NFS. So NFS itself will, you know what, I will just not go over it too much. It will select like a path to go to, and the function names will have, you will again have like a mount root. It will be NFS mount root and not like the local one, NFS stop and so on. Same logic, sort of object oriented, yeah. But we're going to go ahead, set up the parameters, and then call NFS mount, which is actually an executable that is provided with there. I have no idea why. We could just do mount -t NFS, provide maybe the type NFS v3, v4, give the mount options and get it over with, okay? So these are like some of the things, but here you will also have all kind of like networking preparation functions, okay? So let's go ahead and have a quick look at some of like the functions here. So you will see that quite a lot of functions. These are logging functions. Panic we already covered. Maybe we covered load modes. We covered uptime. I mentioned it, that we do like the roundup. Time elapsed will take this and like subtract. Parse numeric we covered it. FS type we covered it, and the IP params and all these functions here, like set net dev from hardware address, are meant to do some initializations, mostly for supporting like either networking, and this is like the DH client. I covered the DH hooks, so we can see that we have like a DH client, and conf file would go like to the DHCP configuration files over there. So it does support this, but the idea is to support NFS mounting, okay? After we support NFS mounting, we can go ahead and do this. So there are quite a lot of functions here that also can serve you if you want to use like NetPlan, or if you want to have support like a network manager. They can serve you for like automatically connecting and things like that, okay? All right. So what I want to show next. So again, we have like the NFS top, NFS bottom, and we'll have like the scripts, and we'll do like, we'll just do the exact same logic, but most of the things are just mounting. So the last thing I want to cover is actually the init, okay? The run-init. So at the very beginning, we had a note about like klibc. So in the past, because it's very lightweight, initramfs would use klibc, which is like very, very, very small. So what run-init does in klibc is this. It looks at the command line parameters, at the argument, and sees like what to do. It receives the parameters for the real root, where we'll switch root, as well as like the init and the arguments. And run-init itself, and what it does is very simple. Forget nuke will be like deleting, forget about it. What it does is this. It changed here to the directory, does some checks, okay? Pay attention, there is also like a driver, and this is the -n. It does some checks to ensure that the directory is not on the same file system. Why? Because this run-init is actually switch root, and switch root deletes everything that is before the directory switch root to, okay? So it's going to check this. it's going to check that you're running on a RAM disk, on RAM-FS. Why? When I say RAM-FS, I mean like on temp-FS probably, because it's going to delete everything. So if you run your hard drive, it's just going to wipe your entire hard drive otherwise. Okay? So if any of this happens, then it says, okay, no, I quit. And otherwise, then it's going to go, and if the dry run happens, it will not do any of like the deleting. Otherwise, it's going to get rid of everything. Okay? This is what it's going to do. It's going to mount like the current directory that we did change root to, which is like this one. It's going to mount it as /. Okay? So this is what it does. Then it's going to chroot, okay? Drop capabilities if need be, and then do the console parameters like duplicating the previous one to this one, and call an execv. Now the moment we call an execv, and we already chroot, which means the root file system of like the current of the process is this one, and it will be obviously after one of the execv as well. We cannot go back. Okay, so this is like what happens. So you do not, at the moment you do like an execv, you cannot go back, you cannot like escape like the chroot jail. Okay, so chroot itself is a system call, the kernel has entry for that. Let's see where. Supposed to be, it's supposed to be in open, I think. Yeah. So chroot itself has one parameter. So it receives this, it receives the file name to chroot into, and we can see that we, if you're already like at the same directory, then we don't need to do like anything. We check permissions, if it connects I can shadir, we check namespaces, and we set the file system to be the one, like the file system of current to be the one that is provided like the path here. So this is what chroot does. Chroot just changes like the directory itself. Okay. So after the chroot, again, if it's not like a dry run, we do the execv. And if it's dry run, we don't do anything, we just stat. So this is the klibc implementation. Now, in busybox, it pretty much does the same thing. So if we go to, I think, libbb, I want to show one little thing about busybox, because the same thing we have like with stat and so on, they will look a little bit weird in busybox because they have all kind of X functions. So if we look, for example, at xstat, we see that xstat is stat followed by an error message and dying if it failed to execute it. So when you see xstat, maybe xchroot as well, let's see. xchadir, xchroot, there are just wrappers around it. And if you ask yourself about, hey, where those are implemented, like the chadir and so on, so on klibc you would have like a minimal libc that is implemented. It's just like the system call things. On another thing you will not have it, so you need to link busybox with another libc, as I mentioned in one of the previous videos where I said that, hey, like here the default busybox is linked with GNU libc on the Debian and Ubuntu initramfs, where you could just, you know, go ahead and put it like link it with muscle or with klibc or with macro c libc, etc. So what we want to do here is go to, I think it's in Linux, util Linux, and we want to look at switch root, like what it does, okay? And the reason for that is that if we go ahead and look for run-init, then run-init is definitely one of like the arguments. This is it, klibc utils run-init, okay? But look what it does. Like, it doesn't really do anything. I mean, this is not code, but like it illustrates like what it is, okay? So it's going to tell like the run-init utility, blah blah blah, yada yada yada. Applet and kbuild hooks are built in switchroot.c. Okay, so we have here like the configuration of the applet and so on, but we need to look at switchroot, which is what I'm going to do. So what we have in switchroot is basically the exact same thing as what we have in run-init on the klibc. So I'm not going to go over like this. This tells you, hey, depends where you run. Do you run switchroot directly, or do you run like run-init? Switchroot will not give you like the -n, the dry run parameter, but run-init will. And let's see what we have here. So as I mentioned before, we have like the X functions. So it's just the same as like the regular function. If they fail, then the process shows a failure message and exits. And so we check if the directory exists. We run stat on it so that we'll see what is the device of it, okay? And if it's the same device, then we will refuse to switch root to it. If the PID is not 1, we will refuse if it's not a dry run. Then we check that init exists, okay? And we check that the mode of it like is not regular, and we check, just like as we checked like in the klibc, that it's not like on a tempfs or like on a RAM disk, okay? Why? Because just like before, we're going to delete everything. So if it's not a dry run, we're going to delete all the contents, and then just like in klibc, like mount the current directory as I remind you, we switched directory, we changed directory before, and so it's going to mount it on as slash, okay? Then it's going to do chroot. On the other one, we had chroot dot or chroot slash, which is redundant because we already did the mount, so it works. And does the console duplication if needs be. And if dry run, it just check access exactly like in klibc, and otherwise does execv exactly like in klibc. So having said that, this is exactly what run-init does, whether without the dry run here or with the dry run here in validate init. So by covering that, we actually covered everything that the initramfs does, how it's built, how it's deconstructed. I'm talking about, of course, like the Debian, Ubuntu, actually also like Red Hat and the likes, initramfs, everything looks pretty much the same. And if these concepts work for one distro, then you can modify this concept or create your own concepts as long as you manage to get a running init for another distro, including a distro of your own. And if you are designing embedded Linux systems, then it's very useful for you to actually write code that does what you need. For example, flashing, for example, another sort of recovery, for example, initializing some devices early enough if you cannot switch to your richer operating system, and so on. So this was, I suppose, much longer than I expected. I'll be honest, I'm not going to cover everything, prepare, and like go and do it again. I'll probably not even edit it. but this, at least, for the sake of completion, it covers what we covered in like one of our recent meetups, and it should give you like an entire understanding of what like the Debian like initramfs is. So what you have to do next is just go ahead and build your own systems and boot them. And I suppose the next video that will be uploaded, if I manage to record it probably in the meetup, would be getting back to one of the systems that like I designed and that have like a minimal RAM disk and does all kind of stuff. We have several systems that we are presenting. Some of them are just meant for like very basic initramfs, like PSG Mini Linux. We have others that would put the Debian file system and so on. So it does not mean that I do not recommend using a build system like Yocto project. It does not mean that I'm not one of the recommended consultant by the Yocto project. It does not mean that I don't use Yocto project for almost everything. And it also doesn't mean that I don't teach Yocto courses or something like that. But these basics are really, really, really useful. Understanding is extremely useful. And if you understand how things work, then it's much easier for you to understand all kinds of design principles that are in other build systems, like Yocto projects, like build root, like the AOSP, like you name it. So that's it, and I hope this video turned out well.